So today we're going to talk about angles of elevation and depression, and we're going to use some trigonometry, and we're going to build on the last 2 days that we've been working on, and we're going to solve some of these real-world examples. So I've got this little picture drawn here. Yes, it's a little not very artistic. I'm not the best artist ever. So I'm going to try to explain to you what angles of elevation and depression are talking about. So pretend we've got, I don't know, somebody standing on a cliff. We're pretending we're in California because we don't have cliffs at our beaches. And we are standing on the cliff and we're looking down at a sailboat. So we have this thing called the sight line. So this person is looking down at the sailboat. And we're going to pretend they're looking at just the bottom of the sailboat. That wasn't very good. Let me try that again. Okay. So we're looking at the bottom of the sailboat. Now, also, you can pretend that somebody's on the sailboat and they're looking up at the person. We're going to pretend that these guys are making eye contact. What we've created here is we've created some right triangles. We have this guy. So this is a right triangle. But also, we have a right triangle right here. If we created a rectangle. Pretend I drew a straight line. There we go. So you always start your angles of elevation and depression from your direct sight outline. So this person that's standing on the cliff, they look straight out. They're looking this way. And they have to look down to look at the sailboat. So right here, looking from here to here, is our angle of depression. Now, if you're on the sailboat and you look straight across, looking straight across is going right here, but you have to look up to look at the person. So from here to here is my angle of elevation. Okay, so we're going to solve some problems where we're going to be using these angles to figure out distances and whatnot. And maybe sometimes we have to find the angle. So you need that worksheet. We're going to look at the side that says angle of elevation and depression worksheet number 1. We're going to look at that side first. So let's look at example 1. Number 1 says, a man flies a kite with a 100-foot string. The angle of elevation of the string is 52 degrees. How high off the ground is the kite? So in this particular example, they've already got a picture drawn for you. That's not always the case. Sometimes you have to create your own picture. So the man is on the ground. He's flying the kite. We have a 100-foot string. So that's where the 100-foot string is. The angle of elevation, so from the ground looking up to the kite, is 52 degrees. And they want to know how high off the ground is the kite. So this is a lot like the first day we did trig. We're missing a length of our triangle, not an angle. So in reference to our 50-degree angle, x is opposite. And 100 is our hypotenuse. So you got to decide which trig ratio out of the 3 relates opposite and hypotenuse. And that is sine. So we're going to use sine here. So we have sine of our angle, and our angle is 52 degrees, is equal to opposite over hypotenuse. So x over 100. So now we need to solve this equation. To solve, we multiply by 100 on both sides. So we have 100 times sine of 52 is equal to x. So if you put this in your calculator, and we're going to use one decimal place, 100 times sine of 52, make sure your mode is in degree, and you get that x is 78.8. Now let's put the units on it. We are dealing in feet because it says foot string. So 78.8 feet. So that is how high the kite is above the ground. Let's look at example 2. Oh, not number 2 on this work. Number 2 says, from the top of a vertical cliff, 40 feet high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? So this is really similar to the picture that I drew at the very beginning of the lesson. So first of all, we got a cliff. So you don't have to be an artist. Oops. You don't have to be an artist. Obviously, I'm not. We got some kind of cliff. And we know that our cliff is 40 meters high. So I'm going to write 40 next to it. We know this is 40 meters high. Okay. Then it says that an object is level with the base of the cliff. So we've got an object somewhere, and here's our object. And it's level with the base of the cliff. And we know that the angle of depression is 34 degrees. So we're talking about from the top of the cliff looking down at the object. So we need to draw the hypotenuse of our right triangle. So the angle of depression, remember we look from our sight line, here's our sight line, and we look down. So our angle of depression here is 34 degrees. So this is 34 degrees. So it asks us, how far is the object from the base of the cliff? So we're looking for this right here. That's our x. Now, but you're sitting there going, well, that 34 degrees is not inside of that right triangle. So this is a right triangle. Okay. So what we can assume is that this angle right here is 90 degrees. So in order to figure out what this angle right here is, we could say 90 minus 34, and we get that this angle right here is 56 degrees. Now we have everything with that triangle that we need. So we've got 40 and x, and we need to determine what they are in reference to our angle. So here's our angle. In reference to 56 degrees, x is opposite, and then 40 is adjacent. So then we got to determine which trig ratio relates opposite and adjacent. That is tangent. So you know we've got to use tangent. So let's set it up. Tangent of our angle, and we're talking about the angle that we're using inside of the triangle, which is 56 degrees, tangent of 56, is equal to opposite over adjacent, so that's x over 40. So let's solve this. We need to multiply both sides by 40. So in your calculator, you need to type 40 times tangent of 56. And we get that x is 59.3. And the units on 59.3 are meters. Okay, so let's look at number 3 on the same worksheet. This one's already got a picture. Lucky us. It says, an airplane takes off 200 yards in front of a 60-foot building. At what angle of elevation must the plane take off in order to avoid crashing into the building? That's actually a real problem. Assume that the airplane flies in a straight line and the angle of elevation remains constant until the airplane flies over the building. So they've already got the picture drawn out for us. We got our angle of elevation. It's from the plane's sight line up. So we want to know what that degree is. Now across from it is 60. So 60 is our opposite. And that makes 200 adjacent. But think about it. We need to be really careful here. This one's kind of got a trick to it. Look at the units. We have feet and then yards. So either we need to convert 200 to feet or 60 to yards. So remember, how many yards are in a feet? There's 3 yards equal to 1 foot. So let's go ahead and convert 200 yards to feet. So if we take 200 yards and multiply it by 3, we get feet. So you get 600 feet. So when we plug this in, instead of using 200, we're going to use 600. Okay, so we need to decide which trig ratio relates opposite and adjacent, and that is tangent. Kind of ran out of room. So let's set up tangent. So tangent of our angle, which we don't know, that's what we're looking for, x, is equal to opposite over adjacent. So we have 60 over 600. So now we need to use inverse trig. So we're going to do our little switcheroo here, and we're going to use second tangent. So tangent inverse of 60 over 600 is going to give us our angle, which is x. So press second tangent, 60 over 600. You get x is 6 degrees.